You might have heard about the generations. So it's not human generation, it's about the generation in garbage collection, which is a technique in C#.net to manage your memory and deallocate the objects and memory or resources in order to provide a very smooth running of your application without having a crash or memory leak. So previous videos and previous series we have seen that what are the managed resources, unmanaged resources, and how to create it, and how to create the object, and small bit of de-allocation of the objects or resources. But in today's video we are going to see in a great detail about what are the ways, as I mentioned, in GC with different generations and other ways through which we can do the memory deallocation and prevent your program from any kind of memory leak or crash. So I'm Vivek Kumar and I welcome to my channel Buddhi Towards Wisdom. So let's begin. So we'll see memory deallocation for managed resources. So it will be a detailed overview. So if you talk about the managed resources, so these are basically primitive types like string, int, array, objects, and float. So we'll see how to, what are the ways of deallocating these variables or objects. So we have the deallocation ways. So we will be seeing one by one what are those. So first comes as automatic memory management. So it is user programmer does it manually by assigning the null value to the objects, and it's very simple. Next comes with the GC with generations. So divides object into generation 0, 1, and 2. So we have 3 generations particularly, and we will see it in some more detail later. So optimize, it is used to optimize performance based on object lifespan. So we have next is using block. So using block is also one of the good technique, and what happens is that it provides a block. In that block we will be declaring the variables or objects. So after execution operation of within that block, it gets deallocated. So again we will see the more detail on it. And the final is dispose pattern. So dispose pattern, it is basically iDisposable interface provides a standard way to release managed resources, and the classes that are unmanaged resources should implement iDisposable to allow for a proper cleanup. So here it is used for both the purpose managed resources and unmanaged resources, and they have some kind of block where we decide to deallocate for the managed resources and the unmanaged resources as well. So next one we have the garbage collection. So garbage collections, it is a deterministic. So what is a non-deterministic is that it's a exact time when GC occurs is not predictable, and which can affect time sensitive applications. So this we have to take care, and it has, again as we discussed, it's a 3 generations. It has a 3 generations, and we will be talking next about some of the key objectives of GC. So first comes as a reclaim unused memory. So here we use the reclaim memory occupied by the object that are not longer referenced. So here it comes in that category. Second comes as optimize performance. It reduces memory fragmentation and optimize application performance. So this is also really required. And the last objective is minimize developer burden. So automatically memory management task, allowing developers to focus on writing code without worrying about the manual freeing of the memory. So these are the key objectives. Next we will see exactly like how GC works, but before that, GC works by identifying which objects are still reachable and which are not. So it reclaims the memory used by the unreachable object, making it available for future allocation. The GC uses a process called mark phase and sweep phase. So mark phase is that, as I mentioned, that when it is declared, so it marks like which all the objects to be mark it for GC. So for example, here C is there, E is there, and F is marked. Now what will happen, it will be marked and converted into the sweep phase. So once it goes into the sweep phase, so we have here the C, E, F, and what happens, one by one it gets sweep off, and the final things comes as when it gets sweep off, the final things comes as A, B, D, G. So this is the speciality of it. And if we talk about the generation in GC, so we have first generation, which is called a 0th generation. So here it is not from 1 2 3, it is from 0 1 2. So now again, if you talk about these generations, so purpose is again the handle newly object created. So the whenever first time an object is created, it comes into this generation 0, and frequency is most frequently it gets collected, and generation 0 happens most of that time. And if you talk about the typical object, it is the created and discarded quickly, like local objects. And again, since it is a frequent, so it can be discarded very quickly. And if we talk about suppose strategy of it, so it object survive GC0 and then it will be a part of GC1. So what happens that whichever object are survived in generation 0, which is referenced, means the object which are referenced, these are go for the GC1. So the next will be the GC1, but before that let's visualize one more time. So here what is there is that we have a C, E and F again. So all are referenced. So now what will happen that slowly these guys leave the references, means the object which is getting created is no longer in use. So what will happen, except these only A, D, G would be left, and it will be referenced to the generation 1 of it and survive for the next generation. So whichever is referenced, it will be again survive and it will move to the next generation. So again, the purpose of generation 1 is like short-lived but better than generation 0, and it is little less frequent. And since it is a less frequent, we can check about, again it is generation 1 purpose we have already discussed, and this collection frequency is very less frequently. And if we talk about the typical object, so who survive in generation 0, it will be a part of generation 1. And strategy is which survives in generation 1, it goes to or it promotes to generation 2. So we have a final generation in garbage collection is generation 2, and the purpose is it's a long time object. So for example, if you have stored if you have newly created object 0, it is still referenced and survive 0 generation 0, it goes to 1. Again, if survives in 1, it goes to final generation, and here it stays for a long time. And if you talk about the different strategy, so strategy would be expensive, keeping it because the object we are keeping it for a long time, and of course it will be expensive, and whenever it requires, it triggers. So in a nutshell, if we talk about the conclusion, so we have generation 1, 2 and 3. So here it is mentioned as 1 1 1, but you can consider as generation 1, 2 and 3. So what happens here, it goes if you talk about the conclusion, so we'll say what is the conclusion is. So we have generation 0 1 2, and in 0 newly created object which is very short-lived and collected very frequently. So once the reference is over from that created object, it gets swipe off generation 0, and whichever is left, it comes into generation 1. So we'll talk about generation 1. So generation 1 is a mid-lived and collected occasionally. Again, the few of the object whose reference is removed or no more reference, it will be a part of sweep and flush, so it will get flushed, and whichever is alive and whose objects whose reference is still there, it goes to the generation 2. And generation 2 is long lived and rarely collected, so it stays there for a longer time. So means objects are still be referenced and will be used by your applications. So we'll check about some more detail about generation of 0. So it would be a simple gen 0 collection, and in a great detail. So we have a class GC example, and you have a main static method. Inside that, suppose we are collecting from the generation 0. So this is the object byte, temp object we created, and we are going for the forcing a GC collection. So we can force also GC collection. GC collection has some algorithm where you cannot predict like what exactly when it gets triggered, but you can force it, and we can call for generation 0. So the next, it will be promoted 1 and 2. When it gets promoted to 1 and 2, just we have seen, but in a programmatically way. Again, we have a class GC generations, and we have created an object of byte, long lived object, and these are again get collected from generation gc.collect 0, gc.collect 1 and 2. So these are the movement of the GC which triggers GC collection to move to surviving the objects. So this was all about.
So I hope that you would have get a very good knowledge or idea to how to deallocate or manage your resources or object in terms of memory management for mostly managed resources. So we have other techniques as well in the pipeline or into the next video maybe, where you can see what are other ways, maybe using or disposable pattern in terms of unmanaged resources. But for this video, we have been talking about the managed resource deallocation. I hope you would have got at least some idea and some better idea. So in order to learn more, you can see the previous video, and about the next series of unmanaged resources about the deallocation, you can see the next video. You can browse the channel and you can learn many things about the C#.NET techniques and many other ideas of memory management. And if you have any questions of any concern, please write into the comment section. Together we will fix it or solve it. So till then, please keep learning, and I wish you very nice rest of your day, and please take care. Bye bye.